Hello, dear aspirants. This is Dr. Sourav sir's class. We are solving our National Boards of Higher Mathematics previous year questions. This question is from year 2021. So the question came in our PhD entrance examination for NBHM. This question is from our linear algebra. So the question tells us that among 3 cross 3 invertible matrices with entries in the finite field Z by 3Z, that Z mod 3Z, that can be pronounced as also Z3, containing 3 elements. So how many are similar to the following matrix, which is the diagonal matrix 2 2 1. Okay, 1. So what can be done for this thing? So we can firstly say that our eigenspace of 2 has dimension 2 because because both the 2 has different eigenvectors. As how can we know that? If they share the same eigenvector, so then the matrix will look like this, and this Jordan block. Okay, then the matrix will be, then 2 will share the eigenvector, so the dimension of the eigenspace will be would be 1. So now here our eigenspace, that can be written as E lambda also. So our E lambda of 2 is what? No, I am writing this. Dimension of E lambda is what? 2. That is our geometric multiplicity of 2. So now, to count the two-dimensional subspace, let me write it. To count the of our Z mod 3Z cube, we can what? We can choose. Let me write it first, then I will explain the thing. Okay. So to count the two-dimensional subspace of Z mod 3Z whole cube, we can choose a non-zero vector in 26 ways. We have to mind that there will be 26 ways to choose a non-zero vector. Then after that, what can be done? After that, also another thing can be written as a linearly independent vector in 24 ways. Now we have to divide by the number of the bases of two-dimensional vector space on number of the bases of two-dimensional two-dimensional eigenspaces of 1. That will be what? Sorry, two-dimensional vector. No. Firstly, we have to think about the vector space, no? Two-dimensional vector space. So our basis of the two-dimensional vector space on Z mod 3Z. Okay. Then what will we get? We will get my 3 square minus, we know the formula, no? The formula is our p square minus 1 and p square minus p and all. If the dimension will be n, then that would be my p to the power n minus 1, p to the power n minus p, and dot 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 to our p to the power n minus p to the power n minus 1. So the same thing is applied here. So we will get this thing 9, and no 9 minus 1 will be 8, and 3 square minus 3 will be 6. So 8 into 6 is my 48. So my, yeah, this has what? This has my 26 into 24 by 48. That means 13 two-dimensional subspaces. Okay. So now after that, we now the number of the one dimensional eigenspace of 1. Now we have to find the number of the one dimensional eigenspace of 1. So we can choose the vector in which ways? We can choose the vector in my 3 cube minus 3 square ways. So that is what? That is my 27 minus 9 equals to 18 ways. We are finding what? We are finding the, yeah, number of one dimensional yeah, eigenspace of 1. So that can be choose by choosing one. We can choose a vector in our 3 cube minus 3 square equals to 18 ways, but we must divide by the number of non-zero elements of a one dimensional vector space over this. This is my 2. So that will be, yeah, we must divide by the number of non-zero elements of a one dimensional vector space is over that 2. So so this will be my 18 by 2 equal to 9 waves. So therefore we will get what? The number, so we will get the number of matrices equals to 13 into 9, so 117 matrices. Yeah, this is the correct answer of the question. They have asked that what? They have asked how many are similar to these following matrices. So we have to find, so we have found the two-dimensional subspaces and then the basis of the two-dimensional vector space, and after that the two-dimensional subspaces there are 13, and for the one-dimensional subspace we firstly get, we chose one vector, so we can get it by 18 ways, and for the and but for the division by the number of the non-zero elements of the one dimensional vector space over z by z by 3z whole cube, that is 2. So we get divided 18 by 18 by 2, we will get, so we got our 9 ways, and the number of the matrices will be formed can be 13 into 9, that is my 117 matrices. This thing is the similar matrices with the given matrix. Okay. Hope you understood. Thank you guys.